Hello and welcome to my first YouTube project. In this project I will be emulating a computer game. As you can see on the right, I will be using the game Doom. Why Doom? Well, I actually have a library which makes it really easy to use Doom in Python. So there's this library called DoomViz, which allows me to make a custom app to my liking. I will be using this to train a neural network which will predict the next frame based on my inputs. The strategy will be to give my model, which is in my case a neural network, a few previous frames with their corresponding inputs and let it predict the next frame. So how would this work? Well, first I will encode the frames into a more compact form. This new representation of the state, also called latent space or feature space, will improve the overall training process. The inspiration to use this method is from a video of CaryKH. You should really check it out. I will put the link in the description. Then I will concatenate the latent space representations with my inputs, giving all the information my model will need to predict the next state. This extrapolation process is achieved with another part of my model. Finally, the newly predicted state will be transformed into an image with the decoder and also added to my previous states, such that I can repeat the process again to predict the next frame. In part 1 of this project, I will be focusing on the encoding and decoding. In the next video, I will be doing the extrapolation process in order to complete the whole model. So encoding and decoding. There are two ways I can think of to achieve something like this. Method 1 is to use an autoencoder, which is a model that has the goal to reproduce the input as good as possible after the information has been squeezed through a bottleneck. This bottleneck will force the encoder to preserve information as much as possible in a given amount of values. I choose to try both 16 and 32 values in my project, but it can also be way more, but as long as it's way less than the original amount of data. And the decoder should learn to map the dense latent space back to an image. The whole model will be judged on the difference between pixel values squared. Another method could be something that uses a GAN. This is kind of the same as an autoencoder, but the other way around. So you will start with a latent space and generate the images first, followed by discriminator. That model will determine whether or not the image is a forgery or not. The training of such a model is divided into 3 different objectives. The generator creates an image as an attempt to fool the discriminator, to let it think it's a real image. The discriminator tries to recognize the forgeries made by the generator. The discriminator is also exposed with true art in order to obtain reference knowledge. Enough of all the explanations, you're probably really stoked to see how this all went down. So let's just jump into it and start with the autoencoder. It takes just a little while before it gets the rough map layout. First gets the ground right and the hand and the gun, also like the sidewalls and the ceiling. Mainly the ceiling in the back, and the monster takes a little while, or is not yet done, so let's just speed it up and see how this will go. Okay, it has been a couple of days already, and the monster is sometimes really amazing, but most of the time not. So yeah, but everything else looks really amazing. I'm actually really happy with the result. Like, if the monster is not done, I think I can live with it. We maybe have a boring level, but it's something of a game, I think. I can kind of understand why the monster is harder to get based on how the autoencoder works. So the autoencoder is actually optimizing based on every single pixel value. So the monster just plays a very small role in the overall scene. So I just think that the autoencoder is just playing it safe by ignoring it sometimes. Let's see if the GAN will do better. The objective system of a GAN is quite different from an autoencoder. So I wouldn't be surprised if the GAN would actually do way better than the autoencoder. I tried 4 different versions of a GAN because I wanted to see if it would improve the result, and maybe also like which kind of strategies I could apply in order to use the GAN in the overall project. In the bottom left you see my base GAN model. I also added something like a patch GAN method, which I hoped would improve the quality of the result, which it actually kind of didn't. In the top right you see a conditional GAN, in which I added the state of the game that includes the position of the monster and of the player. And finally, in the top left you see my model in which I added an autoencoder, in which the GAN and the autoencoder both share a similar part of their model, in this case the decoder and generator part. As you can tell, it doesn't look that great. I think I could probably make it look nicer by spending a bit more time on the base model GAN. But I could be really bothered because I already have a very good result of the autoencoder anyways. I also found out that the state of the game didn't really make much sense, so I think that a conditional autoencoder wouldn't work anyways. Maybe I just misinterpreted state, or maybe there's some bug in the code, I don't know. So yeah, let's just go back to the autoencoder and see what I actually learned by investigating it a bit more. I did this by turning all the latent space values into sliders. I can drag a slider and see the new frame in the bottom left. In the bottom right I put an image that shows the difference between the adjusted frame and original autoencoded frame. I named the sliders after what it's kind of doing. There are a few cool ones, like this one which changes the wall. And this one, it changes the flame. And of course the gun. So you can retract the gun and you can put it back up again. So yeah, that's about it for this part. So what we will do in the next video is put the frames of the game through the encoder and use these latent space states to predict the next frame of the game. And of course we also put all the pieces together and play the game. See you next time.